Guys, I have a problem about this frequency response for a pair of poles in M9. So, can you all help me about this?
Yes, but first, let us recall what the lecture has taught us about.
Hi everyone. So do you know what is frequency response? So normally frequency response is defined as a quantitative measurement of the frequency output spectrum of a system in response to the stimulus. So it is used to characterize the dynamic of the system. So frequency response is a measure of magnitude or phase of the output as a function of the frequency in response to the input of the system. So as you can see from the graph here, so this is actually the Bob plot to plot out the frequency response. So this is to show the magnitude in response to the frequency, and this is the phase in response to the frequency.
But I still not understand about that. So, can you please explain me more details about this?
Okay, let me explain to you. So first, you need to know that frequency response for a pair of poles only function when only a pair of poles exists. So this is the equation, and then after that we separate this equation into a partial fraction, and we substitute the value of z with exponent j omega. So after we substitute the value of z, we will get this equation. Okay, as we look at this equation, the h omega will become maximum when the value of omega is theta and negative theta. Okay. Now we look at this figure. This figure is for stable and causal system. When the value of r is in the range of 1 and 0, when the value of r increase, the value of h omega magnitude also increase. This can be clearly seen in this picture. For example, this is for the poles is at 0.3. When the value of r increase, the value of magnitude of h omega also increase. Look at this. The value of r is 0.5, 0.7, and 0.9. So as the value increase, the value of h omega at the poles increase.
Since Izati has explained to you on this topic, I think you can try to do some sample questions. Let me find some examples and explain to you. I think these questions are quite good. Maybe you can try it. So for this question, we need to plot magnitude of h omega for hn equals to 0.8 un. So to plot this kind of graph, we need to find the location of poles and 0 and the maximum of h omega. First, we need to change it into Z transform by using the formula. So we will get this. Then substitute Z equals to Ej omega into it. We will get h omega. Then to find the maximum of h omega, we need to make our E minus j omega equals to 1. So I get my omega equals to 0. By substituting omega equals to 0 into it, I can get my maximum equals to 5. And to find the location of poles and 0, I can use hz and multiply z for both numerators and denominators, and I get my zeros at z equals to 0 and poles at z equals to 0.8. And we can start to draw our graph. 0, z equals to 0 at here, and poles at here. When the poles is approach to 1, my amplitude of h omega will increase, you see. When I open it, it will become like this, and my maximum will be 5. So for the second question, we need to plot magnitude of h omega for hn equals to 2 alpha n cos omega naught n un. Like just now, we need to find the Z transform first. Using this formula and substituting hn into it, I can get this. Because this one is un, my n equals to 0, I need to convert it into h omega by using this trigonometry equation. I can get this one. Then after I rearrange all these things, I can get this. Using this equation, I will get this. Then e minus j0 will become 1. Then this one, e minus infinity will become 0. So the outcome will be 1 over 1 minus this one. This one also same. To get the maximum, I need to make my omega equals to omega naught and omega equals to negative omega naught, so that my e negative j omega minus omega naught will become 1. So if the question gives me alpha equals to 0.4 and omega naught equals to 90 degrees, I can get this. Then when I substitute omega equals to 90 and negative 90, I will get my maximum at 2.38 for both. To get the location of poles and zeros, I need to convert it back into Z transform and multiply both numerator and denominator with Z. And this one. Then my 0 will be Z equals to 0 and poles will be Z equals to 0.4 EJ 90 degree and its conjugate. I draw the graph. It will be 0 for both, and then poles 90 degree and the R will be 0.4. Here also 0.4. So my graph will be like this. When I open it up, it will be should be here. So the maximum will be 2.38. Okay, that's all for the graph.
Anyone know why should we need to learn this?
Yes, I know. Based on what you guys have taught, we can relate the frequency response pair of poles and zero using low pass filter and high pass filter. So as you guys can see, please don't criticize my drawing because I know it is such an awesome drawing. So we know this is 0, 90 degrees, and this is 180 equal to pi. Wow. Okay. So this is frequency pair of poles, and this is zeros. So what should we can conclude is it works as a filter. So from this we can draw it like so. This is poles, and then before that let me this is 90, this is 180. So when it start from poles, so this is 0, so we should start from here, and then when we meet the poles it gone higher, so until it meet 90 degrees, and then it should go down because we meet the poles, we meet the zeros after the 90 degrees, and we meet the zeros and then here the response. We can say it is work as a low pass filter. So other than that, zeros and this is poles, so I can say it will work as high pass filter because we can draw again. This is not 0, 90, 180, and this is 0, 90, 180. Then when we start from zeros, it start from zeros and then until 90 it gone higher because what? Because we've made the poles. We made the poles until it made the 180. So I can say it is work as high pass filter. When should we use this? If we want to record the sound or signal, then we can receive any unwanted signal, like there are more high signal. So we use low pass filter to remove high signal, and we don't want the low frequency. We use high pass filter to remove low frequency. So you guys understand?
Yes.